Welcome to 8.3, and our less than essential question is, how can I use sine and inverse sine to solve for unknown sides and angles? So, if we remember before, we had SOHCAHTOA, S-O-H-C-A-H-T-O-A. Tangent was what we learned on 9.1 and 9.2, and that's tangent is opposite over adjacent. Today, if we're using sine, it's going to be sine is opposite over hypotenuse. So let's get right into it. So sine ratio of an acute right triangle in a right triangle is the ratio of the length of the opposite side to the length of the hypotenuse. So if I'm standing here as my reference angle, my opposite side is the same opposite if I had tangent, and hypotenuse, there's only one hypotenuse. It doesn't matter if I'm here or here. Hypotenuse is always hypotenuse. Opposite and adjacent would switch depending on my position, my reference angle. So use the right triangles to calculate the values of 30, sine of 30, sine of 45, and sine of 60 degrees. Leave your answers in exact values. That's going to mean we're not going to use a calculator. It's actually easier. So the sine of A, or 30, would be opposite, if I'm here, my opposite is across 4 over hypotenuse 8, which would be 1/2. So I could say sine of 30 degrees equals 1/2. If I want to do sine of B, I'm going to have to change my reference angle. So now I'm here. The sine of 60, and I did that math, they're complementary angles, so 60 plus 30 is 90. Sine of 60 is opposite, well, opposite in this case is 4 square root 3 over a hypotenuse, which is 8. So I can simplify this to the sine of 60 equals, that's 1/2, but it's square root of 3 over 2. And then I have to do sine of 45. The sine of 45 degrees opposite, this is where I'm standing, is 8 over hypotenuse, 8 square root 2. So sine of 45 degrees would equal 1 over square root of 2. We normally don't write square roots in the denominator, but I'm going to let it slide this time. So let's actually do this with some math now. So we have this beautiful tent, and it says that the first cable is 30 feet. What is this? 30, and the second cable is 46. And that the angle up here is 40 degrees. And this angle, the big one, is 55. So I'm going to put that this is just 15 there. We want to find the height of the center pole and the distance between the two stakes. So my reference angle is up here. I'm here. This side would be my adjacent side, and this would be my opposite side if I'm up here. And I have to find the distance between them, so I'm going to find this side. So I'm going to say the sine of 40 degrees equals opposite over hypotenuse 30. I want to get opposite by itself, so I'm going to multiply each side by 30. So I'm going to go and put in my calculator 30 sine of 40. Times the sine of 40. And as with tangent, I wanted to make sure my calculator is in degrees. So this is going to be 19 point, and we'll round to 3. So this is 19.3. And then I want to find the whole distance, and then I could subtract to find this one. That would be the sine of the whole angle, 55, equals opposite unknown over hypotenuse. In this case, the hypotenuse is 46. So I want to multiply each side by 46. So in my calculator, I'm right. 46 times the sine of 55. 46 times the sine of 55. And I get 37.7. And the difference of this bit would be 37.7 minus 19.3. Subtract 4, subtract 2, carry the 1, 8, and 18.4. And my units are in feet. So this is 18.4 feet. We want to find the height here, and the height is adjacent. But, lucky for us, we could actually stand right here. So, you're going to pause the video, you're going to do this problem, where now this is opposite, 30 is still hypotenuse, and I have to find how big this angle is, and it's going to be complementary to this angle. Welcome back. So hopefully you figured out that this angle is 50. So I'm going to have the sine of 50 equals opposite unknown over hypotenuse of 30. Then multiply each side by 30. So this goes in my calculator. 30 times the sine of 50. And I get 22.98, so I will just round that to 23 feet tall. So that's how we can use it to find length. We can also use sine, but it would be the inverse sine to find a missing angle. So same process as inverse tangent, but you're going to be using opposite and hypotenuse. So the inverse sine or arc sine of x is the measure of an acute angle whose sine is x. When you know the length of any two sides of a right triangle, it is possible to calculate the measure of either acute angle by using inverse sine, or this is inverse sine on the button of the calculator. So here we have a right triangle. When sine of A is x, unknown, and inverse sine would be inverse sine of x, tells me the measure of A. So we know that the sine of A is 2 over 5. So opposite over hypotenuse is 2 over 5. I would then just use my calculator, inverse sine of 2 over 5. And the reason I do that is if I want to get rid of sine, I inverse sine it, those cancel, I have to inverse sine both sides to keep the equation good. So how do I do inverse sine? I go to my calculator, I hit second, the sine button, second makes it blue, 2 divided by 5, and I get 23 point, and we'll say 6 degrees. So I'll do one, then you'll do one. So determine the ratio of sine of B, and then use the inverse sine to calculate the measure of B. So I'm here. Opposite is across from me. Hypotenuse is across from the right angle. Sine of B. Well, sine. So opposite over hypotenuse would be 11 over 25. How do I get rid of sine? So B is by itself. Inverse sine. So B is the same thing as inverse sine of 11 over 25. I go to my calculator and I do inverse sine, second sine, 11 over 25, and I get 26.1 degrees. So B Okay, so you guys pause the video and you guys try this one. So calculate the sine of the angle measure for y. Okay, welcome back. So if y is where I'm standing, it's my reference angle. Opposite would be 5. Hypotenuse is across from the right angle. I'm going to write the sine of y equals 5 opposite over hypotenuse 12. Inverse sine both sides, so y equals inverse sine of 5 over 12. Go to my calculator, inverse sine of 5 divided by 12 gives me 24.6 degrees rounded. So y equals 24.6 degrees. This problem was in the book, and I thought it was hilarious because we all live in Italy, and many of us have been to the Leaning Tower of Pisa. But it says the Leaning Tower of Pisa is a tourist attraction in Italy. It is on unstable land, and as a result, it really does lean. So, with this problem, we're going to calculate the angle of the lean. So the tower's height at its low side, so that would be here down, would be 55.68. And on the high side, which would be here, it's 56.7. The top of the tower is displaced 3.9 meters, and I want to find this angle. So this opposite would be 3.9. We're using sine of the unknown angle theta equals 3.9, and the adjacent of this side of the tower would be 56. 0.7. Inverse sine both sides. Those signs cancel, so I'm going to put in my calculator inverse sine of 3.9 over 56.7. Second, inverse sine 3.9 divided by 56.7. Enter, and it's at 3.944. Now, for this problem, I'm probably going to keep it at 3.944 degrees. And then if we measure this again in a few years, and it was then 3.954 degrees, well, I can see that there's a difference. If I just rounded to 4 degrees, and then this would be rounded to 4 degrees, I wouldn't know if the tower is tipping more or not. Okay, so for this lesson, there is a you do it. You're going to go to page 569. You are going to match the scenario with the picture, but you're only going to match because during the you do it talk, where you're going to be answering this question, how can I use sine and inverse sine to solve for unknown sides and angles, you're going to be solving some of these in the talk. So, good luck on the math and Delta Math.